Welcome to the lecture. Today we are going to see the problems on admittance matrix. Here we are going to solve the problem for admittance matrix using direct inspection method. Let us see the example. Sketch the power system network for the given data and form the bus admittance matrix using direct inspection method. In this tabular column, they have given the element, that is 4 elements are given. Then they have given bus code 122, 123, 324, 224 and their respective impedance. Now, so based on the given data, now we have to draw the power system network. That is, here the maximum number of buses is 4. So we have to draw the power system network with maximum of 4 buses. For example, you can take this is bus number 1, this is bus number 2, this is bus number 3, this is bus number 4. Now we have to connect the line. Bus number 1 to 2, the impedance is J0.6. Bus number 1 to 3, J0.5. Similarly, bus number 3 to 4, J0.5. Bus number 2 to 4, J0.2. So, in this given data, directly they have mentioned the line value as a impedance value. But sometimes they may not indicate, simply they have given the value. And based on the given value, you have to identify that whether it is impedance or admittance. Now, the given reactance value is positive, so that we have to take it as a impedance. Now we are going to form the bus admittance matrix using direct inspection method. Now, so we can form the diagonal elements first, then we can form the off diagonal elements. Now, diagonal elements. So totally we are having 4 buses, so that we will have 4 diagonal elements, that is y11, y22, y33, y44. Now first we will determine the value of y11. So y11 is equal to the number of elements connected at bus number 1. Now at bus number 1 there is 2 lines are connected, that is line 1 to 2 and line 1 to 3. So we have to write y11 is equal to y12 plus y13. But here they have given the impedance value, so that we are rewriting the equation as 1 by Z12 plus 1 by Z13. So now the value of the impedance of line 1 to 2 is J0.6. So we have to substitute those values. 1 by J0.6. Similarly for 13, J0.5. So 1 by J0.5. So if you simplify this numbers, we will get y11 is equal to minus J3.67. The unit of admittance is mho. Similarly, we have to calculate for y22, that is number of lines connected at bus 2. So there is 2 lines are connected, that is y21 plus y24. Similarly, we have to write 1 by Z21 plus 1 by Z24. Now the impedance value of line 2 to 1 is J0.6 and the impedance value of line 2 to 4 is J0.4. That you have to substitute and simplify. We will get y22. 1 by j 0.6 plus 1 divided by j 0.2. If we simplify this value, we will get the equation as the value of y22 we got j 6.67 more. Similarly, for y33, the number of lines connected at bus number 3. So at bus number 3, there are two lines are connected. One is line 3 to 1 and line 3 to 4. So we are writing the equation for y33 is y33 equal to y31 plus y34. So by writing in terms of impedance, 1 by Z31 plus 1 by Z34. Now the impedance value of line 3 to 1 is J 0.5. That is from the network. That is 1 divided by J 0.5 plus similarly for the line 3 to 4, the impedance is J 0.5. So now the Y33 value become minus J4 more. Similarly, we have to solve for Y44. The number of lines connected at bus number 4. There are two lines are connected at bus number 4, that is line 4 to 3 and 4 to 2. So Y43 plus Y42, that is equal to 1 by Z42 plus 1 by Z43. So the impedance value of line 4 to 2 is J 0.2. This 1 by J 0.2 plus line 4 to 3 is J 0.5. So if you simplify these values, Y44 will get minus J 7 more. So now we have completed the calculation for admittance, that is diagonal elements. So the other name for diagonal elements, we can say it as self-admittance elements. Now we have to determine the off diagonal elements. Off diagonal elements. That is, here totally we are having 4 buses. So we have to calculate y12, y13, y14, y21, y23, y24. Like that we have to calculate the off diagonal elements. Now we will calculate for y21. So or y12. That both are same because the admittance matrix is a symmetrical matrix. So whatever the value we are determining for y12, that will be equal for y21. So y12 is equal to minus small y12, that is equal to minus 1 by z12. So now the impedance for line 1 to 2 is J 0.6. So if you simplify this value, you will get J 1.67. So Y12 is equal to J 1.67. That will be equal to Y21. Similarly, we have to calculate for y13. y13 equal to minus small y13, that is equal to minus 1 by z13. So z13 value is j 0.5. So minus 1 divided by j 0.5. So if you simplify this, we will get y13 equal to j2, that is equal to y31. Similarly, we have to calculate the other diagonal elements also. Y14. Here there is no line connected between the bus 1 and 4. So from this problem, we have to check whether the line is connected between 1 and 4. So here in this network, there is no line connected between 1 and 4 and 2 and 3. So it becomes 0. So for this network, y14 become 0. y14 equal to 0, that also equal to y41. Now we have determined y21 value, y23 value. We have to determine the y23. y23. Now from the network, we know that there is no line connected between bus 2 and bus 3, so that y23 also 0, so that will be equal to y32. Now we have to calculate y24. y24 is equal to minus small y24, that will be equal to minus 1 by zt24. So the impedance value of the line 2 to 4 is j 0.2. So if you simplify that, y24 is equal to j5, that will be equal to y42. Similarly, we have to calculate y31 already we have calculated, y32 already we have calculated, y34 we have to calculate. So y34 is equal to minus small y34, that will be equal to minus 1 divided by z34. The impedance value of the line 3 to 4 is j 0.5. So if you substitute that, 1 divided by j 0.5. So after simplification, we will get y34 is equal to j2, that will be equal to y43. Now we have determined all the elements of the off diagonal elements. So here totally we are having 4 buses, so that we will get the 4 cross 4 matrix. At last we have to write the y bus matrix, that is y bus equal to, we have to write y11, y12, y13, y14, y21, y22, y23, y24, y31, y32, y33, y34, y41, y42, y43, y44. So now from this we have to write the all the admittance elements. So we know that y11, y22, y33, y44 is a self-admittance elements, and all the off-diagonal elements are mutual admittance elements. So from that we have to write the bus admittance matrix, that is J 3.67, J 1.67, J2 0, that is y11, y12, y13, y14. Similarly, y21 is j 1.67, y31 is j2, y34, sorry, y21, y31, y41, that is 0. Now y22 is j 6.67, y23 is 0. Similarly, y32 is 0. y24 is j5, y33 minus j4, then y34 is j2. Now y41 is 0, y42 is j5, y43 is j2, and last y44 is minus j7. So this is the formation of bus admittance matrix using direct inspection method. Thank you.